Hi, I'm Professor G. Welcome. Today in this lecture, we'll be looking at Newton's third law. So if you have not watched my other videos on Newton's first law and second law, make sure to check out those. Also, subscribe to my channel, share it with your family and friends, whoever needs it. Hit that bell icon to get my upcoming video notifications. All right, let's begin then. So far, we have treated forces as a push or a pull. Yet these push or pull, cannot exist alone, and they have to be a part of the interaction between two objects. So let's say I have a wall. So this is my wall, right? And then let's say I'm going to push on to the wall, right? Right. So as I push onto the wall is also pushing on my hand. How do I know that? Because of the bent fingers. Do you see that? Bent fingers. So that tells me that as and when I exert a force on the wall is also exerting a force on me. So let's take an example here, right? Let's say I have this object and I'm going to place this object on the floor, and the object exerts a force on the floor, correct? What do we call that? Weight, yeah? Floor also exerts a force on the object, right? True. We call this as support force. So we call this as action and reaction. So Newton's third law states that every action has an equal and opposite reaction. So applied force is basically the action, and then the reaction would be the other force from the other object that it exerts on the original or the first object. So let's say first object exerts an action on the second object. So second object exerts force which is equal in magnitude and then in the opposite direction. Okay, so let's talk a little bit more on this action and reaction. The action and reaction are both forces. One exists because of the other, so they always exist in pair. And then these forces are equal in magnitude and opposite in direction. So let's take an example here. Let's say I have two objects of equal masses. So I'm going to call this as object 1, right? And then I'm going to call this as object 2. So object 1 exerts a force on object 2. So I'm going to call this as F1. F1 is a force that an object 1 exerts on object 2. So same case, right? From Newton's third law, object 2 also exerts an equal force but in opposite direction. So I'm going to call this as F2. So in equation form now from here, right, F1 and F2 are equal in magnitude but opposite in direction, and this is the equation form for Newton's third law. So let's take an example of a rifle and a bullet as shown in the figure there. What we know about this is rifle is obviously larger in mass compared to bullet. So that's the reason I have this, bigger mass and a larger looking M, and then I have bullet mass which is smaller compared to rifle, so it's smaller M. So now from Newton's second law that we have, which says force equals mass times acceleration, that we have already seen. Another form of Newton's second law is, F over m equals acceleration, and in this case we are actually calculating the acceleration using force and mass. Okay, so taking this into consideration, if I have the same or constant force, or the force is not changing in this case, what do I have? I have a relationship. I can take the same thing, right? It's a constant force, so I can substitute or ignore force in this particular equation and write the same equation as if I'm ignoring the force. This equation becomes 1 over m equals acceleration, and that's what I have here. Okay, so I'm going to look at that equation. So what do we know about this? We know acceleration is inversely proportional to the mass, right? From Newton's second law. What that means is higher the acceleration, lower is the mass of the object, right? Or in other words, if the object is small, then it moves faster, or higher is the acceleration. Now, if the mass is higher, right, then the acceleration becomes smaller. It moves slowly. Let's say, for example, I have 10 newtons of force, right? Force is constant, so I'm just going to take it as 10 newton. I'm going to apply on a small object like this, 10 newtons. It's going to move faster, it's going to accelerate faster. I apply the same 10 newton, let's say, on an elephant. What do you think? Is it sufficient? No, because of the larger mass, acceleration might be smaller, right? Comparatively smaller compared to the acceleration of a smaller object, as in this case, this one. Okay, so bullet is smaller than the rifle, so obviously acceleration is bigger compared to the rifle acceleration. And this is how, action and reaction pair goes hand in hand. And that's your Newton's third law for you guys.